All right, it's 11 o'clock, so we will get things going. Thanks everybody for joining us. Today, we are taking a look at new features in Bluehill software that are rolling out in our July 2024 release. Thank you so much for being here. I'm Nick Erickson, your host for this webinar. Today, I'm joined by Dan Caesar, the product manager for all of Instron's static testing software. This includes Bluehill Universal, which powers our universal testing systems, and Bluehill Central, which is our lab management application, both of which he will be covering today. So with that said, I will turn things over to Dan to get us started.
All right, thank you, Nick. I am just gonna share my screen, so bear with me for a second. Screen. All right, everyone should be seeing the agenda at this point in time. And I just want to, let me just move the bar. There we go. Very good. So again, yeah, thank you, Nick, and thanks everyone for tuning in. And like we always do, we're just gonna start with an agenda. But first things first, most of this session, I'm gonna be, of course, in either Bluehill Universal or Bluehill Central. I'll be sharing my screen. The best way to view this is to try to just maximize the screen itself. So if it's not already standard, if Zoom hasn't already set that as your standard kind of way that you're viewing the content, just try to play around with that now to maximize the screen share. But yeah, to set the scene, today we're just going to be talking about the new features, kind of highlight the largest features that we're introducing in versions 4.47 of Bluehill Universal that's coming out any day now, and Bluehill Central 1.24. That typically we do releases for both of these applications once or twice a year. We add features, we fix things that have been reported. But this particular release for both of these applications have a lot of good kind of juicy features that we felt it would be good to highlight them in this session. Obviously, as we go through here, some of them are going to be applicable to you, some of them might not, but yeah, you can pick and choose as we go through. And then as Nick said, we'll share some content afterwards that lets you review these things. We're going to have a page on our website that kind of highlights these latest features. Every last detail that's put into these releases is always going to be in our release notes that we can also send for those that request that. But that kind of sets the scene, and I really just want to jump into what we're going to cover today. So we're going to start in Bluehill Universal, and we're going to be talking about our pass-fail workspace component and a new sample pass-fail feature. Then we're going to talk about a new export capability that allows you to reduce the number of raw data points that's exported in our export files. Then there's a feature that creates a new soft key if you have digital output lines controlling different devices that your test system uses. And then the last Bluehill Universal feature that kind of has a number of things to it is our auto-injector system. So kind of the meat of this release is coinciding with a new system that we're introducing at Instron for our static product line, the auto-injector systems for testing different pre-filled syringes and auto-injector devices. And it coincides with a heavy set of features within Bluehill, new method types that we're gonna introduce. And then also a feature called system suitability that allows you to run daily transducer checks on the different sensors that you might have for your auto-injector system. So we'll certainly go into a lot of detail for all of these different items. Specifically for auto-injector, there's a lot of collateral and things that you'll find on our website. I believe we're also having a webinar next week where the product manager for that product will be going into a lot more detail about that system and sharing some of the same features that I'll be talking about today. But I just wanted to do a brief introduction into the new method types and system suitability for that system. And then we're going to switch gears a little bit. We're going to go into Bluehill Central. And the 124 release that's about to come out, it introduces a few different very useful features in how you manage files within the lab management module. So there's a search field for files. You can preview and print things. You can do bulk file operations. So that's what we will do after Bluehill Universal. And then as always, we will get to any questions that you might have. So as I'm going through these things, if something pops into your head, don't wait till the end. You can just enter those questions into the chat immediately, or and I will get to them at the end. There was a few registration questions that I'll also get to, so you don't need to reiterate those if you know you entered those questions in at the registration phase. But all right, so let's get out of the PowerPoint and get into Bluehill Universal. So as you can see, this is Bluehill Universal. I am running version 4.47, which is about to be released, as I mentioned. I'm in a demonstration mode right now, so I'm not connected to a system, but that's no problem in terms of demoing what we're trying to see today. And we're just going to jump right into the first feature. And let me just get my agenda so I can just follow along. So the first one is sample pass fail. So if I go into an existing sample just to show off this feature, this is actually a preview of a feature that we'll be talking about later, system suitability. But if I open up a sample, that ever since we launched Bluehill Universal in 2017, that we've had a part of the workspace that users can configure optionally that's called the pass-fail component. And it's always been associated to individual specimens. So I've opened up a sample that already has data in it. It's a test where I have 3 specimens. It looks like there's 3 separate hold blocks of different forces for this particular test that we're looking at. But if we kind of hone in just on the test-based component itself, this pass-fail, this big green check mark, that it's telling us that our specimen 3 has passed, meaning that any of the calculations or results that you care about that have failure bounds associated to them, it's just indicating whether or not it's passed those failure bounds, whether it's within spec or not. And so you can see specimen 3 is good, specimen 2 is good, specimen 1 actually has failed. And so we have it indicated in this workspace component, but also in the results table, you'll see an icon associated to that same failure condition. And if you click the icon, it'll tell you that, okay, this is because in your specimen 1, when you're evaluating the error at this 400 Newton hold, that it's greater than the bound that you've configured of 0.02 Newtons, and the error is 0.035. So that is why we see that specimen 1 has failed. And so what we've introduced in this version is now we can actually evaluate not just independently specimen 1, 2, and 3, but if you have a statistic, so if you have mean or median set up associated to one of your results, that when you are configuring your method and you're setting up that pass-fail component in your workspace, so if we go into the method tab, we go to the workspace, there's a pass-fail menu, that you'll see there's a new drop-down that says display. And so this is where the user can choose whether or not they care about just the specimen, just the sample, or maybe you want to show both the sample and the specimen in that workspace component. So if I go back now to the workspace, you can see there's actually 2 different statuses. The top one is associated to the sample, and the bottom one is associated to the specimen that you you've selected. So that is essentially what the feature does. What one thing that is obviously needs to be configured when you do want to set up your sample pass fail is that the failure bounds need to be assigned to a statistic. And so to do that, similarly, we can go into the method to your workspace where you are setting up your results that you care about. And so these are everything I have on my results table. And if we look at, say, the one that I truly care about for the sample, which I've set up to be the average error. So if I go back to the test workspace just to see what that is, that again, we're holding load at 200, 300, and 400 newtons. And we're evaluating the error that we see when we take a point at each of those holds. And so we have, of course, an error at each point. Those have average errors. But then if we care about saying, okay, we need to do 3 runs of this, and then we need to evaluate whether or not the mean of those 3 runs falls within a tolerance, that's what we're referring to about the failure bounds for mean and median. So it kind of batches all of your specimens together and then has bounds specific to that. So if I change this to actually induce a failure, I can maybe make the tolerance significantly smaller and make it 0.05 newtons. And so if I make that change and head back to the workspace again, you can see that in this result where we have a calculation with failure bounds on the sample mean, that now we had indicated that the sample is out of tolerance. So that's sample pass fail. The last thing I'll say before we move to the next feature is that we have not only kind of these icons, but for individual specimens, you can add to your results table a column associated to the status of that given specimen. And so similarly for the sample, it's not appropriate to put it on your results table, but we did add a method parameter so that you can, on the top of your PDF report that you're generating, you can indicate whether or not the sample passed or failed. So if we go into your export and your report, there's a method parameter associated to sample pass fail. And so that allows you to indicate whether or not that that sample passed or failed. So at a future date, we might add that similar text right here, but for this release, that you can add that new sample pass fail to your report in the way I just described. Okay, that's the first one. The second feature is our data point reduction. So to do that, what I'm going to do is stay within this sample, and I'm going to edit the layout to just put our raw data viewer where that pass fail component was. And you can see for each of these tests, we're collecting how much data? We're collecting 604 data points. And so what this feature allows you to do is say that, okay, I know that the test collected 604 points, but for the purpose of the CSV file that we're trying to output from the system, I don't need 600 points. I need something less than that. So people might do that for a couple different reasons. The first reason is maybe 600 isn't the best representation, but you might have a sample that has thousands or tens of thousands of data points. And if you're running a lot of tests, that can produce files that are pretty large. So if you're trying to save on file size, maybe you want to take something that has 25,000 points and bring it down to 1,000, because that's all you need when you're referring to that file in its CSV format. But what's critical is that you want to retain all of the data. You don't want to just capture all, like, you don't want to change your data collection settings for the test to only capture 1,000 points, that you need those 25,000 points to be able to perform the correct calculations, and to have the curve that you want to see and refer back to if you need to open up the Bluehill sample again. But maybe for the purposes of your analysis or where you're storing that output, that you do want to reduce the number of data points. So that's one reason. The second reason that we've heard is that you might be using that CSV and putting it into some external program or putting it into an external database that's expecting a set number of points. So for those cases, you might have a test that has you don't know how many points are going to be captured due to the nature of the test itself. And so if your limb system or something is really looking to just plot a curve with 1,000 points, not 25,000, then you can guarantee every specimen that is run and every CSV file that's output will have that consistent number of points. So those are a couple of reasons that we created this feature. And the way that you set it up is if we go into the method tab and we go to exports, which we already are in. And if you navigate to either your export 1 or 2, which are the same thing, where you can just choose different content. And then we scroll down to where we're actually defining the content that's getting exported, that if you do care about raw data, you have that enabled, and then you'll see this new selection that says reduce raw data points. And so if you turn this on, then you have a couple decisions to make. It defaults to a single domain and then it defaults to a domain that just is the entire test. So start of data until end of data, and 100 points. But you can choose up to 3 domains where you can have specific parts of the test where you might want, say, 500 points for your elastic region, because that's where we want that amount of data for that particular region. And then once it yields and we just have kind of the plastic region for an extended period of time, we only want 250 points for that part of the test. So it allows you to define different domains. And so just to kind of demonstrate that, if we go back and just look at the test curve that we're working with again, that we have this load at 200, a hold at 200 newtons, a hold at 300, and a hold at 400. So maybe all I care about is just trying to get these hold periods, and that I want to only have 25 points, for instance. So maybe not realistic, but if I want to do that, I can go into reduce raw data points, set it up to 3 like I have. I can click my expression builder to build the domain. And so because I'm using test profiler in this instance, test profiler, when you're trying to define the different parts of that test, it just gives you all of the steps that you've created. So I can just simply say, okay, I want my first hold at 200 to spit out 25 points, my second hold at 300 to be the next 25, and then the final hold at 400 newtons to do 25 again. And so now if I go in and just do an automatic save, sorry, just to spit out the CSV itself, and let me just save this as a different name. And then export to that location. And just show you what that looks like. So I just saved it to Central. So I'm just gonna retrieve that CSV, which I saved in our SST file, and I'll just download that, open it up. That here's the CSV I just created. And if I just say insert a scatter plot that you can see, I have just 25 points from each of those regions. And then if I look at the total number, that it's the 75 that I'm anticipating. So that is our second feature that 447 introduces. So let me get back out of here. The third one that we're going to talk about today is the new soft key. And so you can configure soft keys in a couple different areas. You can go into the system details areas, but if you do have access to the method, they're configurable on your console, because the soft keys, they are available to within the software, which we'll see, but they're also on your handset if you do have a system that has a handset. And so you can go to the soft key menu, and you'll see that there is a new available soft key that is toggle a digital output. So when you do enable, or if you add this soft key, you just have to do a couple things. And so you can have more than one if you want. Maybe you have more than one device that you're trying to control, but let's keep it simple and just keep it to one for now. And you're just going to tell Bluehill which line I care about. So for instance, we are going to be talking about our auto-injector system, but people use digital output to trigger different external devices in either on-off states that your system relies on. So for the auto-injector itself, there's a couple different things, where there's grips or a shuttle associated to the position of a fixture that the system uses. And you can simply set up a soft key to say, okay, I want to have line 1, which you can call whatever you want for on off. You can kind of change these descriptions for when the user is actually interacting with the button. But when you go to your test workspace, then you see this IO kind of icon and the new soft key that we just added here, where if you click it, it will set it on. And then once it's in the on state, the text will switch to indicate to the user that if you press this, it'll shut it off. So for whatever device you're trying to control, there's kind of endless possibilities, but it allows you a simple way to simply toggle on and off, where in the past, you would have to go into system details, you'd have to open up our IO menu, and you'd have to actually go into digital outputs and change the state from on to off to do that same procedure, which of course is a couple more button presses, number one. And then number two, that if your device is actually getting triggered during a test, that you have to remember to go back into that menu and set the default state that the method is anticipating in terms of toggling it high to low. Whereas this is kind of a much more simple way for users when they're setting up a test to be able to do that trigger. Okay, all right, so then that is the digital output soft key. And I'm gonna jump out of this sample to go on to the next section, which is gonna be about our auto-injector system. So like I said before, this is the first version where we're supporting in our standard Bluehill Universal software, our auto-injector testing systems, which we've been shipping for a number of years now, but we're just kind of releasing a standard version of that. So certainly the website has a lot more details than I'm going to cover today, but in terms of what you'll see in Bluehill is that in admin, and you're not going to be changing this, but when you're configuring that auto-injector system, then you'll have this new toggle turned on. And when that is toggled on, that you'll see only methods that system can run. And so just thinking for a second, that before you might see tension, compression, all your different method types, that when you're using the auto-injector system with that toggle on, that we're filtering the other method types, and you'll see just the two method types that are for that particular system, because not only is the software changing, but the system itself has a lot of ancillary accessories that are necessary for running these tests. And so we try to make it simple for what methods are supported in that configuration. So we'll just jump into this auto-injector test method. And we'll see changes. I mean, if we go in, this is the method role, of course, when you're creating a new method. If you are familiar with Bluehill Universal, this is all the same. So all the sections are the same. So it's for someone who's used to Bluehill, it's not a revolutionary change there. So it's easy to adopt. But you'll start seeing some of the changes that we've made once you go into the menus themselves. So the inputs are the same. If you go into specimen, that's where we see the first big set of changes in the specimen properties, because the devices that you're testing with auto-injector systems, the drug delivery devices, are much different than your average tensile dog bone per se. And so there's different geometry and dimensions that we wanted to make specific for this type of test, that we used in the test control to make the creation and maintenance of these methods as easy as possible. So the first thing you'll see that's different is the fluid density. This is something that's associated to the fluid, of course, that's coming out of the device, and it's used in a calculation that is specific for this method type for the delivered volume of the drug. You're going to also see that you can select what type of activation the device has, whether it's a button where you actually have the user injecting the needle with the button, versus one that doesn't have a button and it's just induced by the pressure to the needle shield. And then you'll see dimensions that are specific to these types of devices. So rather than just seeing length that like you might see in a normal tensile method, that you have cap height, height without cap, the gripping distance, a lot of things that are very specific to the diagram associated to the fixtures that our system is shipped with, and the device characteristic itself. So this is, of course, a lot of change for users. If we go to the measurement area, that by default, we're adding mass and click detection, which are new, so associated to the scale that is associated with the device that's measuring the amount of delivered volume. Click detection is that sound that the device makes that many times needs to be monitored of whether or not it occurred. So those are things that are just automatically added. If we go to calculations, that there's two calculations that are specific. One is delivered volume and the other is the injection time. So these are things that the average user is not going to see or not going to need to see. But if you are using an auto injector system, we have just standard calculations that you can grab to get off and running. But then I think the largest set of changes in trying to make our users' lives easier is in this test control area. So if we go into the test, that everything you see here is specific to this method type. And it's something that, again, we're trying to make our auto injector users' lives easier, where in the past we have been shipping these systems, but we were using normal test profiler methods, and they got very unwieldy, and it was a burden for users to figure out the complexity of those methods and how to set it up in all the different steps and trigger all the different devices to essentially do these things. And so we've taken all the complication out of it, and we're now in the test control, allowing users to simply say, okay, are we doing cap removal for this? Yes or no? If yes, you can set the rate associated to that part of the test. All right, for the injection part of the test, how fast we want the crosshead to go, what's the force requirement for the device. Is there a safety check happening? So safety check lockout that happens post ejection. If that's the case, are we doing a lockout check or defeat force? Again, what's the rate of the crosshead during this? What is the force tolerance that's associated to the lockout? And then some positioning details associated to all the interstep movement of how quickly you want the machine to be moving, if there's any sort of clearance that you want to put into those steps. So that is what we've done with our what we've been kind of calling our basic auto injector method. So it's kind of a pre-canned tool for you to just plug in whether or not you're doing these things with your device, and then setting rates and forces associated to your own specifications. So that is the auto injector method. I'll jump out of it quickly. And the second available method type, I'm not actually even going to go into. Well, I guess I can, but it's the auto injector test profiler. So the difference between this and what I just showed you is that sometimes maybe you need to do something a little bit more complicated, and those different toggles that we just went through for the test control aren't going to cut it. And you need to do some fancy movement or some additional steps that we aren't setting up in that basic template. And then that's where you can go in and create as complicated or as simple of a test profiler routine yourself, while still having access to the calculations that we talked about with delivered volume and injection time, and then still, of course, having all of the attributes for your device captured into parameters that you can reference very easily with the test profiler test. So that is the two method types that we've introduced. And in the introduction to the system, again, there's going to be a lot more detail associated to seeing one of those tests actually run. And so I definitely encourage you that if you are interested, to not just look at this video, but to look at the other resources that we'll have for those systems. So another part of the auto injector system that isn't associated to the method type is system suitability. And so system suitability is configured in your system settings. And so if you have an auto injector system, you'll see this available. And really what system suitability is, it allows you to put in a formal control into Bluehill that allows you to check your transducers in any interval that you deem necessary. So what I've set up in this case is I've said, yes, my system requires system suitability, which means that before I run a test, the system needs to be in a good state. And so what I've said is a good state is that I want to check this every single day. And so you can change the criteria for how often your lab requires these transducer checks. That I'd say the most common is just once a day that these need to be run. And a lot of times this type of workflow is it's already happening in labs, but it's all happening outside of Bluehill, and it really requires SOPs to be written and operators to follow those SOPs and to record the values to make sure that, okay, yes, today I hung this dead weight on my load cell to make sure that it's within the right tolerance to do my tests for the day. And typically this is something that labs do to make sure that in between the calibration cycle, which could be 6 months, it could be 12 months for that load cell, that something could happen. Someone could overload the load cell, and maybe it's damaged. and maybe you want to make sure that that before you do your test for the day, that the system is in good working order. And so that's why people do these checks they have been doing these checks for years, but what this does is it integrates it into the software so that a user physically can't run that test until they performed this check. And so start back at the top, you'd have system suitability enabled. You can set your criteria. So it's a time interval, so daily, weekly, monthly, or maybe a custom interval if you wanted to do it every hour, if it was incredibly important. There's also an option to say every single time that we're opening up a new sample, we need to make this check. So there are some labs that have that stringent of a requirement so that every single test, every single new sample needs to have the check performed. And then in this lower section is where we're defining what transducers are we checking. So what I have kind of set up on my system right now is that we're checking the tensile load, so the load cell, at a couple of different levels. And it's pointing to a method where you've pre-configured your pass-fail criteria associated to running that test. And so you can have one or you can have more than one. So if you need to look at a tensile load, you need to test it also in compression. If you had different transducers like an extensometer, or in the case of the autoinjector system, there's different cameras and scales that are being used that people will be adding more than one test to check those different devices. And so you'd name those as necessary. You'd link the methods associated to those routines that the operator is going to run through. And then whenever your criteria is triggered, then the user will be required to run that test. It needs to pass for them to proceed. So to show that, if I back out and go back to my home screen, that it's actually indicating to me right now that I require this check before testing. And so if I go to create a new sample, what's going to happen? I'll say I want to run autoinjector method 1, that it's going to actually check the system suitability settings that the system has configured. And it's telling me that before proceeding, I need to run this test. And so if you had multiple transducers that you were checking, you'd see a list here, but I just have one. It shows that this is the last time that the check was actually run. Right now it's invalid. And it's indicating that I need to run it because I have that check that says every time you try to create a sample, you need to run system suitability. So I will start the system suitability test. And what you'll see is that kind of it denotes the testing workspace, that this is not just your average test, but it is the system suitability test. And I have demo data set up. And so I'm going to run a few tests here. But what is important is that the user is not changing method settings. The user is not changing method settings, that these are going to be kind of very controlled methods that have very specific results tables associated to evaluating the indicated measurement with a reference. And so you'll notice that I was actually using this method for the purpose of the earlier parts of the demo, but I'll get a little bit more into detail. So maybe it will make sense as to why I have these force holds and such. But for this particular test, again, remember I was saying I'm checking my load cell. And one way of doing that is to hang dead weights. I would say it's probably the most common way of doing it. You can also use a spring that has a known spring constant, which is convenient because you can use it in tension and compression to, rather than dead weights, you're kind of locked into just tensile forces. But at each force hold, I'm telling the system, go to 200 Newtons, that you would have prompts as this test is running that will tell the user, okay, it's going to pause the test. It's going to say, hang your 200 Newton dead weight. That can all be configured in Test Profiler. And then you can resume the test, and then it will capture the point at that particular force hold. And then it can ramp up to as many holds that you want to do, or at any, however you want to configure the check to satisfy your own requirements. So in this case, again, I have 3 separate holds. Each of them is indicating kind of what was measured and then what's the actual error associated to it. And so that error value is going to be determined by the known value of that dead weight. So as a part of this system suitability test, you would have identified a dead weight set that has known values that are unable, that the user is not entering in at the time of the test, that it's going to be pre-configured in the method to say, hang dead weight ID 1234, and we'll know what you've configured that method's specific weight to be. Or if you had a spring constant, you could just use a spring constant and calculations to determine the value at any given point. But now that I've run those three tests, you can see there's a secondary curve associated, sorry, a secondary plot that I put up for graph 2 that's graphing the average error. So your lab is going to have some sort of tolerance that's allowable for the error at each of those points. And so again, it's entirely up to what your requirements are. But this is where we're going to be using the sample pass fail to say that whether you need to do just a single run with a single point, or if you need to do what I've done here with 3 separate runs across 3 separate force profiles of the load cell, that the average error that's allowable has passed. And so if I finish this, you're going to get a PDF report just like a normal test that will save this for your own purposes. And then it will automatically kind of come out of the system suitability test workspace, say that you've passed, and it's passing because the sample pass-fail criteria that you've configured has been met. If it failed, it would of course indicate that here. And then you can finish. If you had multiple tests that you needed to do, you would open up the next system suitability to check the scale next. Maybe the first one is the load cell, the second one is the scale, the third one is the camera that's measuring the needle length, that you could have any number configured. And then once you've passed all of them, you could proceed like I just did, and now they're off and running for the day. And then 24 hours elapses, or at any point in that daily period, I guess if you do choose daily, it's just looking at the date that it's run. So once midnight occurs, then it's going to trigger it saying it's a new day and we need to run a test, or the system suitability. So that was the introduction to system suitability. We do recognize, and then feel free to reach out to me or maybe even just add into the chat, that this is something that we've released specifically for our auto-injector users that are in the bio and pharma space, that have all of these different devices, and it's extremely common for them to run this gamut of checks before they run those tests. But we also know that our average user, people that might only care about the load cell, kind of like what I just demonstrated, also would value this feature. So if that's the case, certainly reach out to us because we're looking forward to introducing system suitability for everyone in the future. But in this release, it is isolated to our Autoinjector users. Okay, and so I know there's a few different questions. I'm gonna, the central part is significantly quicker. So I spent a little bit more time on system suitability than anticipated, but we're just gonna jump right into central and show off these features pretty quickly. So the three I wanted to highlight, it's all lives in lab management. And so lab management is where, if you're using Bluehill Central in your lab, it's where all of your files are getting stored. And so the first feature that we introduced is this search field. So you'll just see the search field. You can type in any keyword associated to a file, your file that you're trying to find, and then it will return everything that it finds and kind of give you the location, and you can jump to those locations very easily. So that's certainly an improved way of finding files. Another feature is the ability to preview files. So if I go into, say, my output where all the results are going, and I go into maybe some of the SST tests that I was just running, that if you want to look at a PDF, if you just select that file, there is this preview pane. So that's new and definitely useful. So you don't have to download the file to actually view the PDF. Or if you have the CSV, you can see the output from the CSV. The preview also allows you to print it. So if you want to get a bigger view, you can expand that preview and do what you want to do. You can save it and print it directly from this application rather than kind of downloading it and printing it from Adobe or from Excel or whatever you're using. And then the other two small things that I just wanted to point out while I'm in here is that the icons themselves, so this is just a small thing that I didn't list in the agenda, but if you're trying to differentiate what a folder is, what a method is versus what a PDF is, yes, we've had this file type as a column that's always been there, but just having the simple icon, those are new and specific to each type of file. And then another fun small one is navigation hyperlinks. And so if you don't want to come up all the way over here and say go back a level, then you can use these links as well. So certainly people that already have Bluehill Central installed in their lab, if you are listening to this or if you're seeing the release notes on our website for 1.24, that we definitely encourage the update because I think every user will see value in these simple file usability enhancements. One last one that I'm looking at the agenda that I missed is bulk operations. And so if we look at a particular folder, that's if you need to delete something, download something, move something around, that you're doing that individually with these different icons by selecting the file. But now you can just simply select multiple files and you'll be able to perform bulk operations. So you'll see what you've selected and you'll be able to download, move, and delete those all together. So that certainly is convenient. Okay. All right, so I will now check out the questions. So let me stop sharing. We got 10 minutes. And I'm going to start with the pre-registration questions. And so the first one that we are looking at is, so how do we get, so will the new features flow out to current users through a system update, or will we need to go online and download the new release? So Bluehill doesn't just automatically push and update versions. That a lot of our users have pretty strict requirements on the version that's running on their system. But the way that you can get access to 4.47 or 1.24, there's a couple different ways. You do have Instron Connect, kind of our tech support lifeline that lives on your system, that you will be able to see the new version of Bluehill Universal available for download, that you can quickly grab it there and update yourself. If you don't have that product, that service offering, then you can talk to your local sales representative to get the update. Second question about reference material at the conclusion of the event. So certainly, all of the things that I reviewed, it'll be on our Bluehill Universal webpage, Bluehill Central webpage, where we list the features that have been introduced. The next question, please provide a list of changes, upgrades, modifications that have been incorporated. So again, yeah, we'll have the new features kind of highlighted on the webpage. If you're trying to convince management that this is an update that we need. If you need more details as to every single change, then certainly reach out to us and we can provide the full list of release notes. And let me go back to the open questions in the chat. Okay, so first one, what is the current version of Bluehill Universal, and how would I get it for my Instron if it's not connected to the internet? So I think I answered that. In that case, if you're not, you can, if you do have Instron Connect, it's not just on the system itself in the Instron Connect application. You could go to the portal that is online just at your desk, not at the system, and log in to access the download there as well. But if, again, you don't have that service offering, then you're going to be reaching out to your sales rep. So next, will we see the pass-fail table column list for the mean? So sorry, will the pass-fail table column list pass-fail for the mean? So I think that is likely what I briefly covered, where in the results table itself, the word pass or fail is not going to be in the table, but it can be in a table on the report that says that it's passed or failed. It's just not directly in that results table itself currently. Other questions? For the data reduction, is it possible to limit to a domain but not limit the number of data points? Yeah, so if you want to limit the data capture for a particular domain, you can do that by just using an arbitrary number of data points. So it is inherently a reduction, so that if you do put in, say you only have 5,000 points in your test, but you say, I want to reduce to 10,000, that it's gonna include every point in that domain. That's kind of the workaround there, Daniel. Another question is that the current Autoinjector customers that are using the custom version of Bluehill to run those systems, can they have an update for this new method type, or is it only new? So that, I'd say the recommendation would be to start from scratch, that those customers will need to have the Autoinjector test type. They can build the same test profile or routine that they have in the new software, but I think the recommendation is to, actually, did I answer the question, or are these only for new auto injectors? Yeah, so yeah, to be more explicit there, the method type themselves will require the hardware that's getting released. 3 more questions. We have 5 minutes, so I think we can do this. Will we see custom naming from entered parameters? So i.e. the testing centers with a lot number for the test, and that lot number can be used to create the file name, so users don't have to enter that. So I'll do a little bit more detail here. Let me just quickly share my screen. Continue to share. So the sample name is a fixed text string. We know that that's been a request from a number of users. So in the future, it's high on our list to make a custom string for the sample file itself. Currently, that if you have export files, you can do a little bit of that already today. So if it's as simple as just your lot number, that you can, I believe, do that today, specifically for your export files. So that might not suffice for Walt, who's asking this, but if you do go into your exports, that by default, the file name for each given export is going to match the sample name, but you could configure it to a sample input. So in your case, you could set your lot number to be a sample input, and that's just going to dynamically pull from the parameter that the operators are inputting. So that's what we do today. But again, in the future, we're definitely looking to have this sample file name be something that's expressionable to pull different fields and even concatenate them to create a string that's dynamically created for each sample. Next question. For system suitability, do you need to use dead weights or springs, or can you use the machine to pull at given loads? So I could have been more clear there, that you can use whatever reference that you want. So we have users that they have a golden specimen, and they say that this material we know has a given property. And so you can create a system suitability test that pulls that tensile specimen or that piece of cord apart, and it has a known modulus or a known yield strength, and that's what you use to make sure your system is within spec before you start testing. And you can set up a system suitability test to say, sure, just run my normal test. I'm going to be using this controlled reference material. You can have your reference, your sample pass-fail criteria specified, and that if that specimen passes, meaning that the transducers are seemingly functioning to give us a good modulus, to give us a good yield value or an extensometer strain value, then you can configure those pass-fail criteria as such, and then that can act as your check. Is the data in Bluehill Central backed up only on the machine? So I don't fully understand that. So Central inherently you have different options that you can save to a centralized SQL database. So where your methods live, where your results live, that are kind of stored centrally, that all of your systems are retrieving files from or saving files to. That, of course, can be backed up. You do have the option to also save things locally if you don't want to save certain files on the database, but that's the only instance that you'd be kind of left with a system that's connected to Central, and you're storing things on the local system. Last 2 questions, 1 minute. Are test methods related to a standard like ASTM? Are they modifiable? Short answer, yes. So we do have the full method suite of templates for the ASTM ISO methods that are typically the most common, that they're just templates. So when you're actually creating a method, typically what customers will do is they'll select, I'm running a test to ASTM D638 for plastics, and they'll open that up, we've pre-configured all the inputs and the test control to match what the standard is dictating. But a lot of maybe you have different parameters you want to add, you want to finagle the report to look a specific way, that you're using that template to then modify it and save it as your own D638 method. And yeah, so I think we're at time. I want to respect people's time. I rifled through those. Nick, if you want to try to close it out from here.
Yep. All right. Thanks, Dan. Excellent presentation as usual. So I'll be quick. Just a couple notes. Any questions that Dan didn't get to? It does look like he kind of was able to check off all the questions in the chat right now. So if any more come in, we'll just address those by email. Again, this was recorded, so I will be emailing each of you a copy of this in case you want to go back and watch anything or share. And then, as Dan had mentioned to, alluded to, the Autoinjector webinar, we have more of a deep dive session happening next Tuesday. We have a session at 9 a.m. and then one at 1 p.m. Those are Eastern time. So I did drop a link to register in the chat, but in case anybody joined late and didn't see it, I'm dropping it one more time. I encourage anybody in that space to sign up and check it out, because we'll have the product manager there and our biomedical market manager who will really provide an in-depth review of the new system. And lastly, a survey should pop up once this webinar ends. We'd really appreciate if you could give us your feedback. That helps us kind of look at how we maybe do things differently to improve the experience for everybody that comes to these. So really appreciate any feedback you can give. So with that said, I just want to say thanks again to Dan for presenting. Thanks to all of you for attending. Really appreciate you joining us, and enjoy the rest of your day. Thank you.